In this video, we'll be expanding 3x minus 2y raised to the fifth power. Okay, first, we should be writing out the 6 terms. So whenever you see the exponent here, let's say it's 5, you add 1, and that's the number of terms there's going to be. So if this was 10, there would be 11 terms. So always add 1 to the exponent to get the number of terms. And for this one, what I did was I treated 3x minus 2y as 3x plus negative 2y. So I put in parentheses the 2 terms inside the parentheses that I see here. So that would be the 3x and the negative 2y. And then I separated them with a plus. Now I can add the exponents. So for the exponents, you always want to start out with whatever the exponent you have in the original problem. So here it was 5. So put that in the first term. So it'll be 3x raised to the fifth. And then that specific term will go down to 4, 3, 2, 1, and 0. While negative 2y starts at 0, goes up to 1, 2, 3, 4, and 5. So at any term, if I were to add up the exponents, they must add up to 5, which is the exponent of the original problem. Now I can plug in the coefficients. So I can do 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, and 5 choose 5. The first number is always going to be whatever the exponent is. Then the second number starts from 0, ends up at 5. Okay, now we can simplify. In order to simplify, we can use Pascal's triangles for the coefficients. Now you can calculate these a different way by using this formula. But it's a little complicated and a little time consuming. So using Pascal's triangle, it's a lot quicker. So for Pascal's triangle, if you notice here, you always start with 1 and end with 1. So the first number and the last number in each row is 1. To go to the next row, you have to add the numbers in between. So for example, 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 1 is 3. This next row, we have 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then finally, we have 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. Because the exponent is 5, you want to go down to the fifth row. And you know which row it is by looking at this second number. So that's going to tell you which one to use. So if I were to use these numbers, notice there's 6 of them. Because there's 6 terms, you should look at the row with the 6 terms. That's another way to know where to look at. So I see it's 1, 5, 10, 10, 5, and 1. So I'm going to replace these combinations here with those specific numbers. Now, I did not write 1 because that doesn't have an effect on the equation, but I did plug in 5, 10, 10, 5. Okay, at this step we can simplify. So simplifying is a little tricky. What I like to do is first work with the constants. So in other words, the numbers. So the first one you have 3 to the fifth, and then negative 2 to the 0. Well, negative 2 to the 0 is just 1, and then 3 to the fifth is 243. So that's 243, x to the fifth. Y to the 0 is just 1. So that's 243x to the fifth. The next one, you would do 3 to the fourth. That's 81. And then we have negative 2 to the first is negative 2 times 5. Well, negative 2 times 5 is negative 10. Multiply that by 81, we get negative 810. Okay, and then you just do x to the fourth, y to the first. So you just continue that way. So like for the next one, you do 3 cubed is 27. Negative 2 squared is 4. You do 27 times 10 times 4. That is 1080. And then you have x cubed, y squared, etc. And so this is our final answer.